Welcome. Today we'll be building the RGB classifier using the k-nearest neighbors classification algorithm. As you can see here, we have this data set of RGB color codes. It's about 5,000 records long and 4 columns wide. We have our red value, our green value, our blue value, and our label. Um, the label is the basic color that is closest to what these red, green, blue values represent. And, well, the reason why we have these red, green, blue values is because it is not possible for computers to, well, this is how computers interpret colors. So, for example, let's say we had our first color, which was 20, 139, and 240. 20, 139, and 240. That's a very light blue, and as you can see in our label, that is also a blue. Now let's take a look at the visualization of the data. Just plot this out real quick. We're just going to do some basic data exploration. So, visualizer. This is the whole data set right here. Looking at our legend, you can see that our white is at 255. Let me make that a little bit bigger. That our white is at 255, and our black is at 0. The way I mapped this out was that we had our R for the x-axis, the G on the y-axis, and the B on the z-axis. This looks a little bit off, but I think it's still good here. This is the whole data set, and well, you can't really see much with it right now, but we'll be using this to train and test our model. So let's close that. Now, the whole goal of our model is to basically classify all of those random RGB values into the basic colors, which we'll have them plotted here. These basic colors are on this legend. I'm not going to read them off, as you can see them there. And they are also plotted here on this plot. They're not the same color as they are in the legend. Not really sure how to change that. I apologize for the confusion, but essentially we are trying to map all of those points to the closest value, to the closest basic color that is mapped on this 3D RGB color chart. So let's close that. Alright, moving on, we will be building our k-nearest neighbor algorithm. I'm actually going to start from scratch, and we can go from there. Right. So we're going to need all these libraries. These are just the basic data science libraries here, and here is our machine learning libraries for basically pre-processing, training our model, and testing it. So let's begin by reading in our data set. It's pd read _csv final data.csv head just to make sure we have the right data. As you can see, we have the right data there. So this is great, but our machine learning model can only read numbers. So what we're going to do is we're actually going to map a different number value to each one of those labels. This is called label encoding. see here. So we're going to do label coding, data frame, then we're going to it's not it. Equals label coder, and then we are going to do data frame label encoding equals le.fit_transform and data frame label. So essentially what we just did was we just mapped random, well, I wouldn't say it's random. What we did was we mapped unique numerical values to each one of these labels, and we created a brand new column right here for the data set. So if we take a look, data frame, we're going to take a look at our label encoding. Value underscore counts. Now, as you can see here, we have each one of our colors has a unique label encoding value. You can also see how much of each color we have. This data set might be a little bit biased because we seem to have a lot more green and blue than, well, anything else, actually. So, well, I don't know. We're just gonna run with it, see how it goes. Let's carry along. So now that we have our encoding done, what we're gonna do is we're going to split our data set. So let's do it. We're gonna have x equals data frame. Do red, green, and blue. So red, green, blue. It's gonna be our x values. And the reason why we're gonna have 3 inputs instead of just 2, well, as you saw earlier, we had a 3D plot, and we're gonna have, you know, 3 different types of inputs to determine what our label encoding is going to be. And we're gonna have y is gonna equal to our label encoding. Yeah, it looks about right. Since we have that, we have our x and y. We're now split our data. So we have our train x, validation x, train score y, and validation score y equals train underscore test underscore split. And we will have our x and y value, and our test size will equal 0.2, which is pretty standard. This means that our testing data is going to be 20% of our entire data set, and the other 80% will be our training data. And then our random state, which this ensures that the sampling for the test data and the splitting for the test data and the training data is indeed random, but it's always going to be the same random split each time. We're going to run that. It means everything's working. We're doing well. Now what's left is we need to build our model. So what we're going to do is instead of typing that whole thing out, we're just going to copy that k-neighbors classifier, and then we're going to store that into the thing, to the variable model, and then we'll have our n underscore neighbors equals 3. I'll print out just to make sure we're doing everything right. Alright, so that looks like everything's working fine. Essentially, the way that k nearest neighbors works is that we are finding three of the closest data points to the data point that we want to classify. Well, in this case, we're using three. You could use one, you could use 10, you could use a lot more, but three is it's a pretty good number because it's odd, and so there won't be any uh, contesting for different colors in this case, and you won't have too many neighbors, and so you won't be overfitting your model when you train it, which is also another thing that we're going to talk about later. So this seems to be working well. Let's train it. Yeah, model dot train or fit actually. Model dot fit. And then we have our train underscore x, train underscore y. It's good. Seems to be working. And now we are going to we're gonna test it. Model dot test. Then we're going to have our validation score x. This will be our predicted value of y. Yeah, that's it. Okay. Model dot predict their predicted value. So this is our predicted y. So what we're gonna do is we're actually gonna compare these predicted values to our train values, and it looks pretty accurate from what little we see. But let's give it a sorry, excuse me. Let's give it we're gonna have to test it with our accuracy score. So what we're gonna do is we're gonna use our accuracy score library that we actually implemented, and then we're gonna compare the differences between the two here. So we have our predicted y and then our validation y. Spell that wrong. That's 82%. That's not bad. That's pretty good. Let's see what happens if we increase our neighbors. Let's try out 7. So this seems to work. And as you can see, it actually went up about 2%. That's pretty good there. Let's actually test it with some different values. So what we're gonna do is we're actually going to train the model again, but we're gonna use all of our x and y values, and then we're gonna use model.predict to test out a brand new value. So let's see how this works with I don't know. Let's just try it out with something like this. Yeah, we'll just go with this value, and then we'll see if it can pick this up. So 240, 218, and 19. So it's 240, 218, and then 19. So that's array 10. I actually created a method to get the color name. I'm just gonna copy and paste it since it doesn't really make much sense to write it a second time. So we're gonna run this, and then we're gonna type in return color name. Oh wait. So as you can see, that's yellow, and that looks pretty yellow. You know, that's pretty accurate. See what happens when we turn down the green to about 50. That's mainly red with the dark red. Okay. Let's see if we can pick up this one too. So we're gonna try this out with the 180. 180, 50, and 19. Oh, that's actually really interesting. This one actually says brown instead of red. Um, yeah, I guess you could say that's more of a brown than a red. That's really, huh? It's a really interesting interpretation of that color there. I think I think that might be because we have more brown than red. Yeah, yeah. As you can see here in this data set, I'm gonna zoom in a little bit. As you can see here in this data set, we have 376 brown and only 230 red. Um, so I think that's probably why it's going to be interpreting that as the color brown instead of red. So as you can see, this machine learning model isn't exactly perfect. Um, I think that's a large part of that is because of the bias in our data. It's about 5,000 records, and 1,400 of it is green, 1,100 is blue, and there isn't really a whole lot of white or black, so there's that. But very very interesting model to play around with. Thank you for watching, and I hope to see you again in the next video.